Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over question number 3 of the 2017 AP Calculus free response question. This question focuses on using the graph of f prime to solve problems. All right, question 3 reads, the function f is differentiable on the closed interval -6, 5 and satisfies f of -2 equals 7. The graph of f prime, the derivative of f, consists of a semicircle and 3 line segments as shown in the figure above. So we have the 3 line segments and a semicircle right here. All right, let's take a look at part A. It says find the values of f of -6 and f of 5. All right, so let's write the plan that we're going to use to solve this problem. Our plan is as follows. We're going to find f. So what you want to notice in this problem is that we're finding f evaluated at a particular x value, but what are we given? We are given the graph of f prime, okay? So to find f given f prime, and also a point, given f prime and a point, what do you think the operation is going to be? So if you have f prime, to go from f to f prime, you differentiate, right? So what do you do to go from f prime to f? You integrate, okay? So the plan is as follows. To find f from a given f prime and a point, we're going to integrate. All right, we're not just going to integrate. Since we're given the points to be specific, we are going to use FTC1, okay? So we're gonna, to find f given f prime, we're integrating using FTC part 1. All right, so that's how it's going to work. Let's go ahead and write down the formula that's going to guide our problem solving process. The formula FTC1 is as follows. So f of b minus f of a, you can think about this as y2 minus y1, or the rise, okay? The rise is equal to the integral of the derivative f prime of x from a to b, of course, with respect to the x. Okay, so we have rise I dab. There you go. Okay, so the rise is the integral of the derivative from a to b. Okay, so let's go ahead and start with the first one. The first one is f of -6. So we want to find f of -6. We're given the graph of f prime. I copied it on the side here so we can just refer to it with ease. We're given the graph of f prime, and we're also given the point f of -2 equals 7. Okay, so to find f of -6, we're given f of -2 equals 7. All right, so this given point coordinate can easily help us to determine what a and b are. Okay, so we have a number line. Which one is to the left of which? -6 comes first and then -2. All right, so when you're setting up your integrals, you want to make sure you're setting it up in ascending order. So which alphabet comes first? A, right? So this is A and that's B. Very important. Okay, so since -6 is less than -2, as you can see my number line right here, that follows that A is going to be the smaller one, B is going to be the bigger one. Okay, and we also know that f of -2 is 7. So what we're looking for is f of -6. So f of -6 is a mystery here. All right, let's set up our integral using FTC part 1. Rise I dab, we have f of b, so b is, what is b? -2, right? So f of b is f of -2 minus f of a is equal to the integral from a to b. So a is -6 to -2 of the derivative f prime of x dx. Alrighty, So let's do it. So we know that f of negative 2 is given to us. F of negative 2 is covered up here. F of negative 2 is 7. We also specified it here. So 7 minus f of negative 6 is going to be, now if you're given the graph of a function, in this case f prime, and you want to find an integral over an interval, what do you do? What is the connection between the integral and the graph of the function that you're integrating, a definite integral? The connection is the following. Let's remind ourselves. We have Navier-Stiller, and we're looking at the integral. All right, so when you're looking at the integral, it could be found using A, which is the area. Okay, so in this graphical representation, the integral from negative 6 to negative 2 of f prime is the same thing as the area between the graph and the x-axis from negative 6 to negative 2. Okay, and also pay attention to where your area is located. If it's underneath the x-axis, your area will be negative, so that's important. All right, so what we're going to be looking for here, this integral is equivalent to the area, let me change my color, is equivalent to the area from negative 6 to 2. So the area from negative 6 to 2 is basically this triangle that we have right here, okay? So it's the area of the triangle from negative 6 to negative 2. Since it's a geometric shape, this area is exactly what the integral is. All right, team? Okay, so let's go ahead and figure that out. Well, we can add 7 to both sides, right? Well, let me set it up first. So we have 7 minus f of negative 6. The formula for area of a triangle is 1/2 base times height. Okay, so for this triangle, the base is 1, 2, 3, 4. The base is 4. And the height is 2, 1, 2. All right, so the area is going to be 1/2 base, which is 4 times height, which is 2. Okay, so f of negative 6 is going to be, so we can simplify this, the 2's cancel out, so we have 4, and then you subtract 7. Oh snap, I forgot my minus. Subtract 7 from both sides, like that. And then negative f of negative 6 is negative 3, which follows that. Divide both sides by negative 1. F of negative 6 is equal to 3. So that's the answer to the first part. All right, so we're going to find the next part, which is f of 5. We're going to follow exactly the same procedure, okay? There's nothing different there. So now we want to find f of 5. All right, we're still given this fact that f of negative 2 is equal to 7. We're going to use this so many times. So let's order our independent variables so we set up our integral correctly. Okay, so negative 2 is smaller than 5. So we want to order it correctly. So negative 2 is smaller than 5. So which is A and which is B? A is the smaller one, negative 2 in this case, and B is 5. Alrighty, so let's just write it again for emphasis. Since negative 2 is less than 5, that follows that our A value is the smaller of the two independent variables, negative 2. A is negative 2, and the big B is 5. And we know that f of negative 2 is 7, which is given. And f of 5 is the mystery. That's what we're looking for. Okay, so let's apply FTC part 1. Rise like dab again. So f of b is going to be f of 5 minus f of negative 2. That's f of b minus f of a. Rise equals the integral of the derivative f prime from a to b, so from negative 2 to 5 dx. Okay. Now, f of 5, we know what f of negative 2 is. F of negative 2 is 7, that's given, equals. Now the integral from negative 2 to 5 of f prime using the graph, how do we do that? We already talked about that earlier, that graphically, your integral is the area between the function and the x-axis. Okay, we talked about Navier-Stiller here. And remember that when your area is beneath the x-axis, that region will have a negative integral value or a negative area. Alrighty? Okay, so let's do this. So we're going from negative 2 to 5. So from negative 2 all the way to 5 is a combination of two geometric shapes. We have a semicircle underneath the x-axis, which will have a negative area, and we have a triangle above, which has a positive area. So to do this, we're going to be looking at the area of the semicircle from negative 2 all the way to 2. And we're going to add it to the area of the triangle from 2 to 5. And that will give us what this integral value is. Alrighty, so in this particular case, we're going to be flexing our geometry muscles to do this problem. So the area of a circle, semicircle, is pi r squared over 2. So area of a semicircle is pi r squared over 2. Area of a circle is pi r squared, right? And then we already know that the area of a triangle is 1/2 base times height, or base times height over 2, doesn't matter. Same thing. Okay, area of the semicircle is going to be, let's not forget the minus because it's upside down. Pi r, which is 2 square, that's for the circle, divided by 2 for a semicircle, plus the area of the triangle is 1/2 base times height, 1/2. The base is 1, 2, 3. And then the height is 2. Like that. Let's go ahead and simplify that. We're going to have f of 5 is equal to, so we add 7 to both sides, okay? Simplify this. This is negative 4 pi over 2, which reduces to negative 2 pi. And then these two 2's divide out, so we have plus 3. And then we add 7 to both sides of the equation, plus 7. Okay, so this simplifies to f of 5 is equal to 10 minus 2 pi. All right, so how was this question scored? This was a 3-point question on the AP exam for 2017. To get the first point, you had to use the initial condition. Okay, so it had 1 point for using the initial condition. So the initial condition is f of negative 2 equals 7. So we utilize it right here, and then right here. So just by utilizing this in your setup, that automatically earns you 1 point. And then you have another point for getting this answer correct. This one is a 1-pointer. And then if you got the second answer correct, you get that one. Okay, so 1 point for getting 3. And then another 1 point for getting the answer 10 minus 2 pi. Alrighty, so for a total of 3 points on the AP exam for 2017. All right, let's take a look at the B part. So in this question, we're going to be learning how to determine the intervals where a function is increasing or decreasing given the graph of its derivative. Okay? All right, so what's the plan that we're going to use for this particular problem? Well, since the problem calls for us to determine where f is increasing, we're going to use the fun chart to see how the to see basically what the connection between f prime and f is. Okay, so the plan is to use the fun chart to connect f prime to the behavior of f. Alrighty, is it the concavity? Is it the sign? So the fun chart will help us to determine what the connection is, and then we can use it to answer the question. Alrighty, so let's go ahead and generate our fun chart. Alright, so we have F, concave up, concave down. There you have fun. F prime, increasing, decreasing. So when F is concave up, F prime is increasing. When F is concave down, F prime is decreasing. F double prime. If F prime is increasing, then its derivative is positive. If F prime is decreasing, then its derivative F double prime is negative. The same relationship goes with F and F prime. If F is increasing, F prime is positive. If F is decreasing, F prime is negative. Okay? All right, so this graph, this chart that we have right here can help us to see the connection between F prime and the behavior of F. So this is our focus right here. We're focusing on this region, okay? Because we have the behavior of F increasing or decreasing, and we have the sign of F prime. Alrighty, so this chart basically tells us that the sign of F prime tells us the behavior of F. Okay, so we're looking specifically for where F is increasing. Okay, so when F prime is positive, F is increasing. So this is a particular relationship that we're looking for. All right, so now we see the relationships. So we're going to be going from the graph. We're going to be using F prime to basically determine what the behavior of F is, okay? So we are given the graph, and we see the relationship that we're looking for here. So let's go ahead and write that down. F is increasing. F is increasing. I wrote is twice. F is increasing when what? When its derivative F prime is positive. Okay, so let's look at this graph and assign sign values to the different parts of the graph, and then focus our attention on where it's positive. On those intervals, that's where F is going to be increasing. Alrighty? Okay, so let's look at the graph. We have, starting from this point is included, we have positive, 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 all the way to 0. Okay, and then over here too is positive, 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 positive. So what's F doing on that interval? On that interval, F is increasing because F prime is positive. Okay, on the other interval that's underneath the x-axis, F prime is negative, 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 negative. So on this interval, F is decreasing on this interval because F prime is negative. Okay, all right, but our focus is on the positive areas because we're looking for where F is increasing. So if you notice in this question, we're to specify where F is increasing and justify our answer. So we need to explain why we said what we said, okay? So F prime is positive on what intervals? F prime is positive on -6 all the way to -2, and it's positive from 2 to 5. So what does that mean? Tells us, so this tells us F is, since F prime is positive on those intervals, F is increasing on those intervals also. So F is increasing on -6 to -2 and 2 to 5. So what's the justification? Well, justification is what comes after you put because. Okay, because, why? All you just do here is just explain what the relationship is as illustrated in the fun chart. Because F prime is what? Is positive on those intervals. All right, F prime is positive on those intervals. That automatically means that F is increasing there. All right, so how was this question scored on the AP exam? Well, this was a 2-pointer. Okay, it was a 2-point question. The first point you get for answering the question correctly. Okay, so we're correctly stating the intervals where F is increasing. So correct answer. correct answer, you get 1 point. So this portion right here is the 1 point part. And then the second point that you get is for explaining your justification. Okay, so if you provide the explanation or justification as to how you came up with your answer, then you get another point. All right, so this second line, because blah 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 blah, that's another point. So for a total of 2 points on the 2017 AP Calc question 3B. Alrighty. For question number 3C, we're going to be doing the following. We're going to be assessed on how to find the absolute extrema. Okay. In this particular problem, we're looking for the absolute minimum. Question 3C reads, find the absolute minimum value of f on the closed interval -6, 5. Justify your answer. All right, so what's the plan here? So this is the game plan. What we're going to be doing, which is basically the consistent procedure for finding absolute extrema, you will use the following. So our plan for the absolute minimum right here, you can also use it for absolute max. We're going to use a method called CVS. CVS check. Okay, so what does that mean? Well, we're going to find the critical values, and we're going to use the critical values and the endpoints to create a sign chart, and then we're going to check the potential extremas we got from the sign chart to see which one is the smallest. Okay, so we're going to use critical values and endpoint to create sign chart. Create a sign chart and check. And check. The reason why we're checking is we want to see which one is the smallest or which one is the biggest. So in this particular case, we're going to be checking the relative minimas to see which one is the smallest. So the smallest one of them is going to be the answer. Okay, notice that in this problem you don't ask for where it's at, you ask for actually what the value is. What is the smallest output value? Alrighty, so let's start with the first part, which is to find the critical values. Alright, so let's find the critical values. How do you find the critical values? Well, the critical values are basically where f prime is equal to 0 or f prime does not exist. We have a graph that we're going to be using to solve these two equations. Alrighty, so what we notice in this graph is from -6 to 5 the function is continuous, so it's defined everywhere. There isn't any discontinuity happening here. Okay, so since f is continuous, or f is defined on the interval -6 to 5, what are we going to just focus on? We're going to consider only the case where f prime is equal to 0, since this is not applicable. F prime equal dn is not applicable in this scenario. Okay, so where is f prime equal to 0? What are the zeros of this derivative function? We have one here and one there, -2 and 2. All right, so those are our critical point. Oh wait, I'm sorry. -2, 2, and then this one right here hiding in the corner, 5. So we have 3 of them. Okay, so let's go ahead and write that down. So our critical values are at x equals -2, 2, and 5. In some questions in the AP exam, they'll just ask you to find the critical values, and there you go. All right, but in this particular question, we're doing more with it. So we have the critical values and we have the endpoints. The endpoints are negative 6 to 5. So endpoints are x equals negative 6 and 5. You notice we have an overlap with the 5s, okay? So these two count as 1. All right, so the combination of your critical values and your endpoints are your potential local extremas, okay? Your potential extremas. So so let's put them together. Our potential, they are not, we don't know for certain if they are yet. Our potential extremas, basically our min and max, are as follows. So remember, potential extremas are basically where you have a combination of your critical values united with your, critical values and your what? Critical values and endpoints. It's kind of like a union too. Okay? All right, there you have it. So our potential extremas are x equals negative 6, negative 2, 2, and 5. Now, what on earth are we going to use these values for? Well, these are the values that we're going to use to create our sign chart. Remember, we talked about the plan? Using our critical values and endpoints, that's what we're using to create the sign chart. Alrighty, so let's go ahead and create our nice little sign chart here. So, see what we have. It's a closed interval, so we're going from negative 6 all the way to 5. All right, so from negative 6 to 5, we're going to have negative 2. It's not perfectly spaced out, it's just a rough sketch. So negative 2 there and 2. Okay, so let's specify our endpoint. So our endpoint is negative 6 and 5. And then our critical values are negative 2, 2, and this endpoint is also critical value. So what we're going to be doing here is this sign chart, we're going to be using it to create a connection between the sign of f prime, again, like we did before, and the behavior of f. Alrighty? So let's do it. So we have, how many intervals do we have here? In this particular problem, we have 3 intervals that we're going to be considering. Let's enumerate them. Interval 1, 2, and 3. So what's the sign of f prime in these intervals? Well, just consult the graph. Alrighty? So if you look at the graph, interval 1 is from negative 6 to negative 2. That's interval 1. We can clearly see that f prime is what? Plus, plus, plus. It's above the x-axis, so it's positive. So it's positive on that interval. What does that tell us about the behavior of f? If f prime is positive, then what's going on with f? Well, let's see. Let's call on our fun charts again. We used that before, but we're going to use it again. F prime, increasing, decreasing. F double prime, plus, minus. When f is increasing or decreasing, f prime is positive or negative. All right, so when f prime is positive, you can see from our fun chart here that if f prime is positive, f is doing what? Increasing. Voila. There you go. So when f prime is positive, f is increasing. Okay? On interval 2, from negative 2 to 2, we have negative. F is negative, 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 negative. Okay? So if f prime is negative, what's happening with f? Look at the fun chart. When f prime is negative, f is decreasing. Okay? So in that interval, f is decreasing. On interval 3, what do we have? Look at the graph. F prime is above the x-axis, so f prime is positive. Okay, so if f prime is positive, what's happening with f? F is increasing. We talked about that before using our fun chart. Okay, so now we can now categorize what our potential extremas are. Are they actually extremas? And if so, what type of extremas are they? All right, so let's categorize them. So this one, you're ascending from this point. So if you're ascending from a low point, that makes that a low point. Okay, so this is a local minimum. Over here, you're increasing and decreasing. If you increase and then decrease, that point where you changed is going to be a peak, right? So this is a local max. You decrease and then increase. If you decrease and then increase, this point right here, this critical value is going to be a valley or a local min. And then when you ascend to a point, that point you ascend to is going to be a local maximum if it's defined. Okay, so in this particular case, we want to see which one is the smallest. So we're going to ignore our relative extremas, our local maximas, and we're just going to focus on our local minimas, all right? So is this one the local minimum, or is this one the local minimum? We don't know. We're going to have to find out what the values are, and then we'll know for certainty which is which, okay? So what we're going to do now is we're going to go ahead and compare f of the function evaluated at 6 and f of 2. Alrighty, let's start with f of negative 6. F of negative 6, well, guess what? We did this particular problem in part 1, where we use FTC part 1 to find the integral, the area between the graph and the x-axis from negative 6 to 2. So we did that already, and we got 3. If you forgot, you can refer back to that part of the problem. So f of negative 6 is 3. Excellent. Now f of 2, what is f of 2? We're going to be using FTC2 again to find f of 2. So to find f of 2, we're going to be using what was given. We're given we know that f of negative 2 is 7. So let me just specify that. We're given f of negative 2 equals 7. So how do you find f of 2 is f of negative 2 is equal to 7? We're going to use FTC1 again, okay? Rise, I dab. So f of 2 minus f of negative 2 is equal to the integral from negative 2 to 2 of the derivative dx. Alrighty? So that's what we did earlier when we're doing the first part. So here we have f of 2. F of negative 2 is 7. So f of 2 minus 7 is equal to, now to get this integral, the integral from negative 2 to 2 is just, it's the area, right? Because the integral and the area between the function and the x-axis are the same thing, okay? So the area from negative 2 to 2 is this semicircle portion right here. But it's underneath the x-axis, so it's going to be a negative area, all right? So the area of a semicircle that's flipped upside down, so it's going to be pi r squared over 2. So we're going to have negative, since it's upside down, pi times the radius, which is 2 pi r squared over 2. Okay, so that follows that f of 2 minus 7 is equal to, if you do the math, of negative 4 pi over 2 is just 2 pi. Okay, negative 2 pi. And then to finish this off, we add 7 to both sides, and that will give us our final answer. Okay, if we add 7 to both sides, we are going to have f of 2 is equal to 7 minus 2 pi. So which one is smaller, 3 or 7 minus 2 pi? You know, 2 pi is 3.1, blah, 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 blah. So if you double that, it's going to be 6.1. 7 minus 6.1 is much smaller than 3. Okay, so since this is smaller, this is going to be our absolute minimum. Alrighty, we can clearly see that. So let's write down what the answer is. The absolute minimum, okay, right here. The absolute minimum is what? The absolute minimum is 7 minus 2 pi. That's the smallest output in this particular scenario. All right, let's take a look at part D. In this particular problem, you're going to be assessed on how to find the derivative given a graph. Okay, how to find the derivative of a point on a graph given the graph of the function. All right, so what's the plan here? We asked to find f double prime of 5 and f double prime of 3 given f prime. So how do you find f double prime when you're given f prime? So the plan is as follows. If you want to find f double prime given f prime, what do? You differentiate, yeah? Okay, you differentiate. And since we are differentiating or looking for the derivative using a graph, how do we find the derivative using a graph? So let's look at Navier-Stiller again. So Navier-Stiller, break it down. So if you're looking for the derivative given a graph, is basically the slope of the tangent line, okay? So when we're differentiating, we're going to be looking for the slope of the tan line, slope of the tan line. And if the graph on that region is a straight line, then that line is your tan line, okay? If you have a straight line, then that straight line is your tan line because the tangent line and the straight line are exactly one and the same. Alrighty, so let's keep that in mind. So let's start with the first part. You want to find f double prime of -5. F double prime of -5 is you're looking for the slope right here. Is the interior point of a straight line segment. Oh, that's easy because our tan line is the line itself. So for that one, this is basically going to be the slope of the line segment from -6 to -2, 0. All right. So just use rise over run to save time. So f double prime of 5 is going to be rise over run. Just create a slope triangle. So from here to there. All right. So your rise is -2 and your run is 1, 2, 3, 4. So it's going to be -2 over 4, which reduces to -1/2. And there goes f double prime of -5. Okay. All right. Now the last one, we have to find f double prime of 3. So f double prime of 3 is right here. Bam. Oh dear. We are at a corner. How do you find, what's the tangent line at the corner? Can you draw a tangent line at the corner? It's impossible. Okay. Remember Coco BD, these are the cases where the differentiation fails, right? Corner, cos, vertical tangent, and discontinuity. If you have any of these, then your function is not differentiable at those points. So we have a corner scenario here. So the derivative does not exist. So f double prime of 3 is DNE because there is a corner there. There is a corner there. Is a corner. All right, but the question asks for an explanation if it does not exist. All right, so saying that as a corner is not a mathematical explanation as to why the derivative does not exist. So if you want to be as specific as possible, we're going to compare the right and the left hand derivatives and show that they're different. Okay, so if the left and right hand derivatives are different at that point, then we know for a certainty that the double-sided derivative does not exist. Okay, so the explanation is as follows. The right hand derivative, which is f double prime of 3 from the right, is the slope of this line segment from the right. And if you use rise over run, we can clearly see that the right hand derivative, you go you rise 1, 2 and run 1, 2. Okay, so that's going to be -2 over 2 So that reduces to -1. So the right-hand derivative is -1. And then we're going to compare that to the left-hand derivative. Okay, so what's the left-hand derivative? The left-hand derivative relative to 3, of course, which is f double prime of 3 from the left, is the slope of this line segment right here, which is you rise 1, 2, and you're on 1. Remember, the derivative graphically is the slope of a tangent line. If you have a straight line, that straight line is a tangent line. Okay, so rise -2 over run 1, which, oh snaps, rise 2, not -2. Rise 2 and run 1. 2 over 1 is 2. Okay, so since the right and left hand derivatives are different, then the derivative does not exist. Okay, so since f double prime from the right is not equal to f double prime from the left, that follows that the double-sided derivative does not exist. Okay, another way to write this notation is you could use the limit of the difference quotient. You can, that's kind of confusing, but you can write that. So you can just say limit as x approaches 3 from the right of f of x minus 3 over x minus 3. This is another way of writing the right-hand derivative. Alrighty, and then for the left-hand derivative, you could have also written limit as x approaches 3 from the left of f of x minus 3 over x minus 3. I just prefer using this notation because it's nicer. Actually, we're looking at f prime right here because we're looking for the slope of the derivative function. Alrighty, so this is basically why a function is not differentiable at corners. Alright, so how was this scored on the AP exam? This is a two-point question. All you just had to do was to find the two slopes and provide explanation where applicable. So this one was 1 point. You didn't need the explanation for that. And then this one is another 1 point, as long as you provided the answer and you also provided explanation. So 1 point for answers and then 1 point for explanation. Alrighty, so that's that. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your preparation for the AP exam, do give us a thumbs up or like. Your positive feedback is very valuable to us. If you have any questions, comments, just post it in the comment section below and we'll be more than glad to respond and support you. Don't forget to subscribe to our channel. We upload videos to our page on a weekly basis, so do subscribe to get updates. More support resources to help you pass the AP exam can be found at our website, mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.